Okay, we're going to do Unit 5A, Section 4, and I want to teach you how to use the graphing calculator. This can be very confusing, so I'm going to go through a couple of examples and have your Section 5A, or Unit 5A, Section 4 notes ready to go, or homework ready to go, because I want to go over a couple of those with you. Some people pick this up very quickly and some people don't. So we've kind of talked about how to find the vertex from vertex form. We've talked about using the trace button, but the trace button isn't the most accurate and only really works if you have whole numbers for your vertex. So now we need to look at what we're going to do if we aren't sure if our vertex are whole numbers and how to find that on a graphing calculator. And this is part of the test. So make sure you're paying close attention and that you might need to review this a few times and practice it a lot. Once you get it under control, you're fine, but you need to practice this. So let's do our normal clearing. Second plus 7, 1, 2. And that should clear your RAM. And then we have everything cleared on our calculator. It's taking a minute for mine to clear, okay? And that way we don't have anything in there that can mess us up. And it should say RAM cleared. Remember, if you want to get rid of this, you can just hit your clear button, okay? But again, we're going to be working back in our y equals area. So let's put an equation, just a plain equation, no decimals yet. And this is one I'm just going to make up. So let's go to y equals. And let's put the equation x squared minus 8x plus 15. Oh, didn't get it. 15, there we go. Let's put that in there. Okay, now what we're going to do is we need to figure out the vertex of this without using the trace button. So first let's look at our graph. You know what? Oh, there it is. I was like, did I mess up? All right, so let's make sure. So let's say I decided, oh, I don't care to listen to Ms. Kavanaugh. I'm just going to use the trace button. So this is what would happen if you use the trace button on this. And this is moving a little slow today, which is good because that'll slow things down. So I hit trace. And it's still not showing up. Hold on. Trace, come on. Where is it? Oh, let's move it right or left. It's up here on the y-intercept, I think. So let's move it, because see it says 0, 15 at the bottom. That means it's way up here on the y-intercept. So that means I need to move it down until I see it. There it is. I'm going to keep moving it till I think I'm on the vertex, right? Okay, well, is that the vertex? Or is that the vertex? Or maybe it's here. Or maybe it's a little over here. Well, we can't just take a guess. We have to have an exact answer. So the trace button really only works if it's a perfect whole number. I mean, it kind of looks like it's here, but maybe it's not. Maybe it's here. And your pixelations might be a little different than mine. So there's a way to do this. And I want you to watch carefully, and you're going to have to review it a couple times. The first thing we're going to do is hit our second key and the trace button. And you're going to get these choices. Now, you have to look at the graph beforehand because you have to decide, is my vertex, am I trying to find out the minimum or the maximum? Remember, if we have a concave up, a smiley face, we're looking for a minimum for the vertex. If we have a frowning face or a concave down, or opens down, then we're looking for a maximum. So in this case, I can actually see mine, but I remember it is a smiley face, so I need the minimum. So you can either use your arrow key down to 3, or you can just push 3, either one. You're going to come back. Now this is where you have to pay close attention. I'm back at my screen, and my cursor could be anywhere at this point. I really recommend before you go to second trace that you put it where you think the vertex is. Now this is where people get confused. I can't just hit enter here. I have to tell the calculator where to look for this minimum because in different graphs there may be more than one minimum. And so we have to bound or put boundaries around the vertex or the minimum that we want it to look at. So that's why it says at the bottom, left bound. We have to put a left boundary, which means I'm going to come over here and I'm going to move my cursor to the left. So I just move it until I'm to the left. Now, it's kind of up to you how far. I could be as far as up here as put the boundary. I could be a little closer. It doesn't really matter. We're all going to get the same answer, okay? What you don't want is to be so close to the vertex that it's not really a left bound. I can't tell, am I really to the left of the vertex here or not? And so I need to move it a little more left so I'm sure that I'm to the left of it. Once I have it where I think I'm to the left, I'm going to hit my enter button. Now on the TI-84s, you're going to get an actual boundary. Okay? On the TI-83s, you'll get the little arrow at the top, which is really hard to see if it's dark. Okay? You can see it pretty easily with mine, but you'll see a little arrow at the top. And what this is telling the calculator is this is the left boundary. Now we need a right boundary because we need a boundary between to look between. So we need to move the cursor till we're sure we're to the right of our minimum. Okay, so it could be up here a little bit. It doesn't have to be exactly where mine is. It just needs to be to the right. So I'm going to hit enter again. And you're going to see now that my calculator is being told, again, tool is only as good as the user, to look between these two boundaries for a minimum. We're not done yet. A lot of people think, oh, good, here it is. We're not done. It is saying, is this where you want me to put the boundaries? Is this the guessing of your boundaries, and is this where you want to look? And in order to tell the calculator, yes, look there, I have to hit the enter button one more time. You know you have gotten to the right, you're at the right place if it says minimum or maximum, okay? If you get an error, it's because your boundaries were not far enough apart. Now you can see with this one, our boundary or our vertex is 4, -1. It looks like it's not exactly 4 because it's 4.000009. Okay? And so I would say we are always usually rounding to the nearest hundredth or tenth, so look for that. So in this case, we could say our vertex is 4.00 -1. Now we know where to look on our table. Okay? Now, let's say I'm asking for the y-intercept, and you don't see it on there, or it's a decimal, then it's not going to show up on our table. There's another thing you can do. We're going to practice both of these. We're going to go to second, calc, and this time, I want to calculate the value of the parabola when x is 0. And so I'm going to choose number 1. I'm going to hit enter. And see how we have the flashing down here? That means I can choose any x I want to find out what the y is. In this case, I want to know, I can't really see my y-intercept. Well, if I'm talking y-intercept, that means x is 0. So I'm going to put a 0 there. I hit the 0. And then if I hit enter, it will tell me that my y-intercept is 0.15. Now, because this one was a whole number, you could have seen this easily on your table. Okay? What I would recommend is that you watch this a couple times and then write down steps that make sense for you. And that's what you're going to want to put on your cheat sheet. I'm going to do one more with you, but mostly what you're going to want to do is listen, write, and then go back and write down some things. So let's go back, and I'm actually going to choose the first problem on your homework of 5A.4. Okay? So if you need to pause it and go find it, that's what we're going to do now. So I'm going to go back to y equals, and I'm going to clear what's in there. And then I'm going to put 1.2 x squared, because I'm just doing number 1 from the homework, plus 3.1 x minus 4. Now, if you hit graph and you get a line or something weird, go back to your y equals and make sure you put that squared on there. That's a common thing that I see people forgetting their square button. Now we're expecting to get a parabola. But there's lots of decimals going on, so I want to see what this is actually going to look like. So I'm going to hit graph because I need to know, do I have a maximum or a minimum here? Okay, so I have a minimum. I want to put my cursor on the minimum so that when I go to find my vertex, I can find my cursor pretty easy. So let's see where the cursor is right now. So in order to do that, hit your trace button, and I can actually see it. There it is. And so I'm just going to move it a little closer to my vertex so that when I go to find it, I'm already in place to put my boundaries pretty easy left and right. Okay? The next step is to hit second, trace, which brings up the calc menu. And in this case, I have a minimum. My vertex is a minimum, so I'm going to choose 3. That brings me back down to brings me back to my graph, and I'm sitting on the vertex. Well, I need to go to the left because the bottom says, what's my left bound? So I'm going to go to the left of it until I feel comfortable that I'm truly to the left of it. And then I hit enter. That gives me my left boundary. Now, the calculator prompts you what to do next. It says I need a right, it's asking for your right bound. So I'm going to move my cursor till I feel comfortable that I'm actually to the right of the vertex. And then I hit enter. I should check and see, is the vertex falling between my boundary? If it's not, you need to start all over again. You need to start back at second trace and do it again, because you're going to get an error. If you're satisfied that your boundaries have now included your minimum, that's your vertex, you can hit enter one more time. And it should say the word either minimum or maximum, depending on which we're looking at, and then it will give you the point that is the minimum. In this case, it's negative 1.29, negative 6.00. And that's what you're going to put in the middle of your graph. Negative 1.29 and negative 6.00. Now I'm going to do a second video where I continue this problem now that I figured out my vertex. Okay? If I wanted to find the y-intercept and it wasn't a whole number, again, to find the y-intercept, I'm going to go back to second, I'm going to go to calc, and I want to do the value this time. So I'm going to hit enter, and I want to know where x is 0 because I want to know the y-intercept. So I hit 0, and then I hit enter. In this case, it is a whole number. On a lot of the homework problems, I think the rest of the homework problems, there's one more that it's a whole number. They're decimals, so you can't just guess at it. I'm going to be able to tell if you just guess at it because you're not going to get it exactly right. You might be close, but I'm expecting yours to match mine exactly, okay? My best recommendation is take this video back to the beginning and watch it as many times as you need to, and then practice it on your calculator. I would write down the steps if you're more of a visual learner. Write down the steps in your own word. What did I do first? What did I do second? And make sure you have this. You have to practice this. So go back to the beginning, start again, and make sure you know how to do all the keystrokes to find your vertex.